Hello everyone. So today we are going to learn about force. So let's start. So we can see there are many pictures, and in each pictures we can see like in this picture we can see that this person is pushing a trolley, this person is pulling this dog, this player is kicking a football, she is punching a bag, and here she is pulling a luggage. So, in all these activities, what are these people doing? What are the activities they are performing? So, basically, first of all, we can see that all these activities is leading to the motion of an particular object, right? But what are they doing? All of them are pushing or pulling like an object, right? So this push or pull is nothing but force, okay? And the force is the thing that is causing the motion of these object. So force changes speed, like if this person is hitting this ball with less amount of force, it will be moving slowly. But if he hit the football harder, this ball will be moving, it will move faster, right? So we can see that force speed up the motion of the football. So now question is, does force slow down the motion of a body as well? So let's see. Yeah, it force can stop the motion. Like a cricket ball stops moving when a fielder catches it, right? So when a fielder catches it, it stops. So force can stop the motion of a object or a body. A football stop when a goalkeeper catches it, right? So force can stop the motion of a moving body. Now, force can change the direction of an object as well. Like when a ball is hit by a bat, the cricket ball changes its direction, right? And when we hit by the edge of board, the striker changes its direction. So force can change the direction. So till now we have learned about three things: that force can speed up an object, force can change the direction of an object, force can stop the motion of an object. So these are the effects that force can cause. Now, in this case, a force is applied when a football is kicked, right? We are applying force basically for kicking this football. When more force is applied, it will like it is hitting this football harder, it will move faster, right? So we can see that force has a size. It means the greater the size, the greater the impact. In this case, we are hitting it with less amount of force, with less magnitude of force. So it is moving slowly. But in this case, if we are hitting it harder, like the size or the value or the magnitude of force is greater, so its impact is greater as well. That is, it is the ball is moving faster when we are applying more force. So this means that force has a size or a magnitude. The greater the size, the greater is the impact. So the size of force is measured in Newton, like we measure weight in kilogram, length in meter, kilometer. Similarly, the force is also measured, and its unit is Newton, which we represent by capital N. This is the SI unit of force. Now force, like in above case, we have seen that we are applying force in a particular direction. Like this man is pushing a trolley. If he want to go in this direction, he'll have to push it in this direction. The man is this in this case pulling a dog. So he is applying force in a particular direction. The player is hitting the football or kicking the football. In this case, he is applying the force in this particular direction. If she is punching a bag, she is applying force in a particular direction. Pulling a luggage, in this case as well, she is applying force in a particular direction. So we can see in all these activities, force is applied in a particular direction. Now, in the above slide, we have seen that force has a size, that is magnitude, it has a value, and it has a direction, right? So force has both the things, that magnitude as well as the direction. So um, the a quantity which has both, that is its direction as well as the magnitude, we call it a vector quantity. So force is a vector quantity because it has a magnitude as well as direction. Like if the quantities which have only the magnitude or only value, we call them scalar quantities, but force is vector quantity. In case of scalar quantity, there is no direction of that quantity. So, but in case of force, we have seen that it force has a specific direction, right? And now there is a question: what is the direction of gravitational force on a stone near the Earth's surface? Now we know the gravity that act towards the center of the earth. So the direction will be towards the center of the earth. That is the gravity. Okay. So what do we conclude? Till now we have learned that force is nothing but a push. Force is nothing but push or pull of an object. So push or pull is called force. Force are always exerted by one object on another. Force move a stationary body, a body that is at rest. It moves it. Force can stop a moving body. Force speed up or slow down a moving body. It can change the direction of moving body. It is a vector quantity, that is it has both magnitude and direction. Now, what kind of force cause motion? Did all kind of force cause motion? Now, so this is the question that must be arising in your mind. Does the same force cause both uniform and non-uniform motion? We know in case of uniform motion, the object cover equal distance in equal interval of time, and in graph is straight line. And in case of non-uniform, object cover unequal distance in equal interval of time, and graph is some curve, something like that, right? So this I'm talking about position time graph. So from graph we can tell about uniform and non-uniform graph as well. Now this is the question: what kind of force cause motion? What is Does the same force cause both uniform or non-uniform motion? So let's see the answer of these questions. So in this case, Sam is pushing this dresser alone, and then he called Harry to push the dresser together. Which between the two is easier? Which one will be easier? Obviously this one, because in this case two force are acting. In this case only one force was there. In this case the two force are combining, so it would be easier, right? Because more force is exerted in this case, so that's why this case is easier when they both are pushing this dresser, right? So let's say um, Sam is pushing this dresser with force of 30 Newton, and Sam and Harry pushes the dresser with 30 Newton, and Harry is applying 65 Newton in on this dresser in the same direction. Now the total force in this case is 30 Newton only. In this case total force is 30 plus 65, so that is 95 Newton. So, and we call total force, we call it net force. Net force is total force. So, force applied in the same direction add up, because in this case we can see that both Sam and Harry are applying force in the same direction. So, we'll add these two forces because they are in the same direction. Now, net force is nothing but the resultant force or the total amount of force. Now, the combination of all forces on an object is called net force. So, net force is combination of all force that is getting applied on an object. How forces combined depends upon the direction of force applied to an object. So, force combined depend upon the direction of force as well. Like in the above cases, Sam and Harry both were applying the force in the same direction, so we add them up, right? So the forces that are in the same direction, we add them up. But as the force is a vector quantity, so we have to consider the direction as well. So a reference direction can be chosen as positive or negative direction, and its opposite direction will automatically be negative. Okay. So, for example, uh, when like if we choose a positive reference direction, so other direction would be taken as negative. If we take yeah, so if let's say this is, if we choose this direction as positive, so the forces that are in the opposite direction, we will take them in negative. So a sign is used to show the direction of force. Reference, if the reference direction is this and that is positive, the other direction we will take them as negative. Okay. So it depend on us which like what we are choosing, or we are keeping our reference direction, we will be taking them as positive. If that is positive, the other one would be negative. So for example, in this case, let's say the Sam is applying force in this direction, that is 30 Newton of force, and the Harry is applying force in the opposite direction. So if I choose this as my reference direction, and I choose this my reference direction as positive, so other like this is my positive, so opposite to this direction I will take as negative. So if I will add them, the resultant force, the net force would be 30 Newton. This is plus because I have taken it as my reference. This is negative because this is opposite to my reference. So I will write negative 65 because it is in the opposite direction. And I will be getting 35, but in the like minus 35, and this negative sign indicate that the direction of the net force is in the opposite direction. This negative sign is nothing but it is showing that the force is in the opposite direction of the reference that I have chosen. Okay. And this 35, this value give us the magnitude of the net force, and the sign tell us about the direction of the net force. Okay. Now there is a question that is, a book is lying on a table, exert a force of 16 Newton on the table due to its weight in the downward direction. The table also exert a force of 16 Newton in the upward direction. What is the net force? So this is a book, and this is applying a force on on the table by its weight in the downward direction, that is 16 Newton. The table is also exerting a force on the book in the upward direction, and this is also 16 Newton. Let's say I take my reference this in the upward direction. I am choosing my reference, so I will be taking my reference as positive, and the force that is opposite to this direction, this upward direction opposite to this, I will be taking negative. So net force will be, okay, just a second, yeah, net force will be 16 Newton. This one is positive because this is, I have chosen my reference. This is negative because it is opposite to my reference. 16 minus 16, that is 0. That means this object will not be moving because there is net force, there is zero net force, and we can see that book is just kept on the table, so it will not be moving. So this is clear that not all kind of force cause motion, right? Now in this case, there are two team 1 and 2, and they are playing the game of tug of war, and the force of they are pulling and they are exerting some force. So all the players are shown are applying some kind of force, so and the force is given, and we can see that this is they are applying force in this direction and they are applying force in this, so forces are in the opposite direction. Let's say I choose this force as my positive reference, so this will be negative because it is opposite to this. So I will be adding these up, and I will be taking like 46 Newton plus 35 Newton plus 29 Newton, and all this will be negative, so I can take the minus common and add them up. That is 63 Newton plus 32 Newton and 26 Newton. So I can add them up, then and I can find the sum of these values as well, and then I can subtract them, and I will be getting my answer. Okay, so we can see this is how we calculate the net force, and net force is basically the force that is showing the impact, right? So like in this case, they both are applying force, but the impact that would be shown will um, only be because of the net force, right? Because if the in both the cases, if they are applying 60 Newton of force, they are also applying 60 Newton of force, none of them will be moving, right? So because net force is zero, so net force is the force that shows the main result, the main impact, right? So let's summarize. So you can fill them up by based on what I thought till now, and this is for practice, and after that you can check your answers as well. Thank you.